Good morning, everyone. Welcome to day 10 of building a simple TCP/IP chat application. This is definitely taking longer than I thought it would. But like I'm going to mention again later, simple and TCP/IP actually don't really go together. I will readdress that when we actually finally get to today what I'm calling a minimal correct implementation. Which right now, and all the way up until this point, our implementation has not actually been complete enough to be correct. So today we should finish off the keepalive messages. That's the goal, and at that point we will have something that's actually I would consider correct. All right, so let's get started. If you got any questions or anything, go ahead and drop them right in the chat, and I will share my screen here. Here we go. Let's jump into it. All right, so let's see. Last time we left off where we can read the keepalive messages. We defined keepalive messages as message type 2. Yeah, so we've got type 2 being keepalive with no payload. Okay, right. Just refreshing my memory. Okay, so we are reading them and discarding them. They don't actually get into our channel of messages, right? They're not considered part of the actual message stream. But now, what we want to do is, I think we actually want to define an actual message type, because now we're going to actually start sending them. So I'm going to have a keepalive message. Now this one could be internal, because the applications don't really care about keepalives. This is something that I want done underneath that application level. So our chat connection is going to automatically send them. Whenever it gets a keepalive, it discards it. It doesn't pass it up to the app. So the application never actually sees keepalive messages. And you can call this, keepalive, heartbeat, whatever. Okay, and that's that's it. There's no fields in this message, so it's just like literally an empty class. All right, that'll work. So when we come into our chat connection, we need to start writing these. Well, let's define how to write it first, and then we'll actually start sending them. So let's add an else if in here. Actually, we don't need a variable defined because there's no fields. So we do need to get the length prefix value, just like our other messages. And we've got this other else if in here. I'm going to clean up this this code in a little bit. Having one of these fancy switch statements essentially is bad enough. Having two of them is definitely not ideal. So let's see. So there's no fields. All that this is going to be is the message type length. And actually that's it. Yeah. Because it even says in the protocol, every keepalive message has a length prefix of 4, which is the message type length. It's the length of the message type. So that's all we need. That was easy enough. All right, now let's write this out. So we've got, we're going to do the same kind of pattern here. We're going to do this, and I'm going to go ahead and just use a span writer just to keep the same pattern going. And then at the end, we advance this position. And you might notice that this is like the same prefix and the same postfix for every one of these. It's another thing I want to clean up. All these are exactly the same lines of code. So we can just pull those out of this else if branch. But I'll do that in a little bit. I want to get keepalives working first. Okay, so we get our length prefix value, which in this case is always going to be 4 anyway. We allocate some memory for the length prefix and that, because the actual bytes going over the wire is going to be 0004, 0002. So then we grab a writer and we write our message length prefix, like we always have to do. And yeah, we have to cast that, don't we? We do. And then we write our message type, which is going to be 2. And that's it. That's how we write a keepalive message to the pipeline, which then gets sent out to the socket. All right, so now we know how to write our keepalive messages. So now let's start actually sending them. And I think what I want to do, in order to send keepalives, you have to have a timer, right? You've got to have some kind of periodic sending. And so what I'm thinking is I'm going to use a timer. Now, we don't want to send keepalives if we're sending other messages. We don't have to send keepalives. I have done it the other way. Sometimes it's just easier, especially like, the first TCP/IP application I ever wrote was before .NET existed, right? It was in C++. There's no async and await. There's no garbage collection. There's no delegates. So trying to write an asynchronous application with those restrictions, the code was just so messy. And I don't know if I actually did this or if this was I just had this for part of the implementation. But at one point I definitely had like a timer, a keepalive timer, that would just always send because it was easier than trying to keep track of, well, I sent this not too long ago. But in the .NET world, we have much higher level abstractions. We can do this more properly. So what I want to do is have a timer. I want to, have a period of time where we send, and we're going to send keepalives, but only if. So what I want to do is have that timer going, but then every time we send a message, I want to reset that timer, right? So we only send a keepalive if we haven't sent a message for the last, however long. And I'm going to keep my timer pretty short, probably, thinking like 5 seconds or something, which is pretty common if you're dealing with, real-world embedded devices, like a lot of TCP/IP applications are. So you're on this dedicated network, you're talking to embedded devices. Short timers are fine over there. Usually on the internet, most things have a much longer time, even on the order of minutes, before a connection can be detected as lost. But for this one, I'm going to keep it short. So let's see. So I'm going to want, when the application creates a chat connection, I'm just going to go ahead and pass in a keepalive time span. So this will be, the actual amount of time after we sent the last message before we send it keepalive. And this, I guess, if I were making this into like a real protocol API, this would probably be, I would probably be adding like an options type here. And this would just be one of the properties on that options type. But I'll just keep it as is for now. Okay, so let's go ahead and save that. Okay, that didn't work. Okay. So we've got this saving into that field, and I also need to create a timer that then is using that. Now, which timer? Okay, system threading timer. I think that's the one that we want. There's also a system timers timer. I think the one that I would want is the system threading timer, which is a little bit lower level. I think you can't change the event handler on it, but that's exactly what we want here. So timer. Let's do this. Okay, so yeah, so we've got this timer callback, and then we can set the due time. I'm not going to use a periodic timer, right? Because one way to do this is just, well, every so often just always send a keepalive interval. If we were going to do that, we would use a periodic timer. What I want to do is have like a single shot timer that then we can cancel and reset, essentially, as we send other messages. So I just want like a single shot timer, and then we will reset it whenever it goes off. So that's the pattern I'm going to use here. Let's see, so we need a timer callback, which is, okay, so I'm just gonna say, let's make a new method for this and just say send keepalive message. And let's see, do I have to pass state? I think I have to pass state. State is, if you're not familiar with it, the idea behind state is a way to avoid some additional allocations of a delegate type, which is usually like sufficiently low level that I don't care. In pretty much all the code I've ever written, I've just never used state. And then we've got a due time, which is going to be our keepalive time span. And we don't want a periodic timer, so we want timeout infinite time span. Okay. That is doable. All right. All right. So we need to actually define this method now. So when this method, or when this timer fires, we're going to call this method, which is going to be, what did I call it? Send keepalive message, right on. And you might be asking, why isn't this going to be asynchronous, just like the send message async? And the reason for that is, well, let's see. So I'm not going to call write async. Instead, what I want to do is try to write to the output channel. If the only reason write async would block is if the output channel is full. And in that case, we've got a back pressure situation going on, right? So I've designed our pipeline and channel to permit back pressure. I'm not that familiar with actually using back pressure in the real world. But the idea is if back pressure is happening, then what's happened is our remote endpoint has its receive buffer full. Our local socket has its send buffer full. And our pipeline is full, outgoing pipeline. And our output channel is now also full of messages going out. Well, in that case, we don't have to send a keepalive message. We have several messages already in flight. So all I'm going to do here with this send keepalive message is to try to write to the channel. If it's already full, I don't care. I'm just going to drop, not send a keepalive message. So that's the reason why I'm not going to use this write async, and it's not going to be asynchronous because it's just going to be a synchronous try to write this. And I'm almost positive channel has the ability to do that. Try write. Yes, and it is synchronous. Perfect. Okay, so I can just say try write with a new keepalive message. I don't actually even care if the write succeeds or not because, like I said, if it doesn't succeed, then we have other messages going out and we wouldn't be sending a keepalive now anyway. If it does succeed, then the keepalive message is on its way out the socket. And then the other thing I want to do here is take my timer and, yes, change it. So we're going to reset the timer to back to the keepalive time span and timeout infinite time span. So we're still not using a periodic timer. So I think that would work. The other thing I want to do is also change this timer when we are sending a message. So anytime we send any other message, as soon as that message gets in the output channel, I'm going to change the timer so that we don't try to send another keepalive for however long. So as long as our users are chatting, we don't need to send keepalives because we're sending the chat messages. All right, I think that looks correct. We also want to cancel our keepalive timer at the point at which we close our socket. So I think I can just dispose it. I think that would work. Or you could do change to infinite and infinite. That would also essentially disable the timer without disposing it. All right. So the one question that I have here is this try write. If the writer gets closed or completed, will the try write throw an exception or will it return false? And that one I'm not actually sure about. It doesn't specifically say, so let's jump over to the docs here and say channel writer try write. Let's see if it says in the actual docs here. It does not. Okay, that's unfortunate. So let's jump into the .NET source code and see what it does, shall we? All right. We've got persistent. Okay. Looks like there is a channel writer in here. Here we go. Oh, that's right, okay. I've looked at this code before. So this is actually just an abstract class, and it's actually implemented in default channel writer or something like that. So we've got channel writer. We're using a bounded channel. I think it might be implemented in this type, actually. So let's see here. So here's our try write. All right. If we're done writing, nothing more to do. Okay, so if it is, so if it's marked complete, it just returns false. That makes sense to me. And the rest of this is all just handling. Okay, so it looks like it'll just return false if that is if it's complete, which is fine. Okay, so let's see if we have. Okay, so where are we at? We're setting the timer, we're clearing the timer, and we're sending keepalive messages on the timer. That sounds good. I do have a question about the error handling. We are right now we're propagating all of our errors up through our input channel. That's what this is doing. My question is, are we going to be propagating any errors into our writer, our output channel? I don't think we're doing that right now. I don't think we really need to. I think we'll get away without that. All right, so let's build this and see if it's working. No, not working. All right. Oh, right, of course, because we didn't actually pass any keepalive values. So I'm just going to define like a default for this instead of updating the apps. I think this has to be timespan.0 actually, because it's got to be a constant, which apparently this is saying. Still not a constant. All right. Timespan is a struct, so timespan 0 I'm assuming is default. All right. So consts are really interesting in C# and .NET in general. Okay. So then I want to have like a essentially this is the logic that I want, but that's not going to actually work, I don't think, because you can't use this operator here. It's not a nullable type. What we can do is it equal to default? Then it's that. Otherwise, keepalive timespan. All right. Same kind of logic here. If we pass in timespan.0, which is the default value, then we're going to make it 5 seconds. That timespan of 0 doesn't make sense anyway. And really, you know, in real world code, you'd want some reasonable limits on this, like, well, it can't be less than a second or something like that. You don't want ridiculous keepalive times. Okay, that should work. Now, let's see if we compile. Yes. Let's jump over to our code here. Don't have this up. TCP client, or TCP chat. Let's bring this up here. And we're going to start up our server and our client. We start a couple clients. Okay, so we've got, let's go ahead and run our server. This is what, chat server, I think. And then our clients. We have a couple of those. All right, so now we've got a server and a couple clients. So now they should be sending keepalives. So first let's just see if the regular process even works. So I connect, not going to do anything. And actually, right, so because I'm handling keepalives at a level like below my application API, our applications aren't even aware of it. So you're not going to see like, oh, I got a keepalive message. Because that keepalive message never even gets into the channel, so neither the client nor the server are going to see it. But both the client and the server should be sending keepalives right now. Let's create a black hole with Clumsy, like we did yesterday, to simulate this half-open scenario. So I'm going to connect over here. We can send back and forth right now. Right, so we can send back and forth. Now I'm going to create a black hole. Haha, yes. Ooh, you know, I wish this thing really remembered the filter that I used last time. Yeah, well, let's see if I remember how to do this. So we've got TCP. Hopefully I don't have to look up the rules again. And what was it? TCP dot source port. 33333 or TCP.distPort, source and destination port, 33333. So I think that's the same filter that I used yesterday. Let's go ahead and kick this off. All right, let's start dropping at 100% chance. Actually, okay, so right now, everything's still happy. So when I turn on this, yeah, I can turn on this, this dropping. I'm gonna create a black hole. And then what I'm gonna do is I'm gonna send a message from one of the clients right away. So it should see its connection drop fairly quickly. And then what I want is for the server and the other client to also detect their connections being dropped, having been dropped with the keepalive timers. Okay, so I'm going to drop, send a message. This one should time out first. It's still trying to send that message and it's getting into that black hole, and TCP is retrying and retrying. You can kind of see that in the Clumsy UI where it flashes green here every time it drops a packet. Okay, so this one timed out first. Now the goal here, oh, okay, there it goes. All right, so this one also detected its connection was dropped, and the server also detected both connections were dropped. So this one, you know, had an explicit sent message and timed out first. These ones both had those keepalive messages that the servers and this one client were sending back and forth, and the server was now able to detect that black hole situation and close those connections. I say these are no longer viable. All right, perfect. So, so now we have a working keepalive implementation, and this, let me turn this off before I forget. And this is the point at which I would say this is a minimally correct implementation, okay? And so what comprises a minimal correct implementation? Well, most of the time you need message framing. Almost always you need message framing, because what you want conceptually is a stream of messages, not a stream of bytes. So you almost always want message framing. You have to always be reading. and that helps you detect those error situations right away. Like on here, for example, these errors are actually coming in from the reads, even though no data is arriving. The send timing out and failing is actually then reported back to the socket, which reports it as a read failure. The socket as a whole goes into an error state. So message framing, always be reading. And a corollary, okay, I can't say that word. A consequence of that, I wouldn't say this is a requirement, but it's a strong recommendation that you use asynchronous APIs. So, some people think, well, I'm just going to use one thread per socket, right? And that makes it easy because I don't have to do any kind of locking or anything like that. I've just got one socket is owned by one thread. That's actually, I wouldn't say, okay, so I don't think it's really any easier, and it certainly doesn't scale as well. One thread per socket is a common idea, but if you're always reading, which you need to, I would say, for a basic correct implementation, then what you really end up with is more like 2 threads per socket. You have a reading thread and a writing thread. And then this scales even worse. So message framing, always be reading, and finally what we completed today is the keepalives. And if you can't use a keepalive message, have to have some other kind of half-open detection and handling. So those are the 3 basic necessities for a minimal correct implementation. So I want to point out something here that I said at the beginning of this stream. We're on day 10. We're 9.5, 10 hours or so into this. And this is from someone who has written other TCP/IP applications in the past. So there is no such thing as a simple TCP/IP application. Like if English was a language that could only express concepts that were possible, then grammatically those 2 words would not even go together. They couldn't even be in the same sentence, right? That's how far apart they are. There is no such thing as a simple TCP chat application. One of the reasons that I chose to do this, there were several reasons that I wanted to kind of make this video series. One of them is about 3 or 4 times a year, someone will get onto Stack Overflow and say, hey, I'm finally learning async and await. And I'm like, awesome, that's cool. And so I've decided to write a little test application, to help me learn async and await. And I'm like, awesome, that's cool. And I've never done TCP/IP, but I figured I'm going to do a TCP/IP chat application. And I'm like, full stop. No. Right. That's one of the worst ways to learn async and await, is to also learn TCP/IP at the same time. So I made this little meme this morning. So this happens a few times a year on Stack Overflow. I want to learn async and await. Instead of taking that one step and just learning async and await using an application that they're already familiar with, or some kind of style that they're already familiar with, they also say, I want to learn TCP/IP at the same time. And I always say, let's not. For a couple reasons. Number one, TCP/IP, I think, has a much bigger learning curve than async and await. Okay, learning async and await is a step, right? It's not. I'm not saying it's trivial, but it is a lot easier than learning TCP/IP. TCP/IP just has a big learning curve. And the other reason that I discourage people from learning async and await by writing a TCP/IP chat application is you end up in this kind of like obscure, unusual usage of async and await. And by that, I mean specifically these main loops. Okay, so let's jump back into the code here. So at several points here in my pipeline socket, I'm using async void here. And I'm using async void with an infinite loop inside of a top-level try-catch. So what I'm really doing here is, this is a top-level main loop, essentially. maybe not top level, but it's definitely like a main loop. This is a loop that should never end. If it ever does end, then it means that the socket has gone away. And I'm using async void for that here, and I'm still kind of iffy. Should it really be, async void? Maybe I want it async task, but then I'd have to pass the tasks up through those different layers, and then that's one more API for the clients, for our applications to consume in order to behave properly. So there's a trade-off there, and I'm just going to keep it async void now for simplicity. But this is like a really obscure kind of usage of async and await. And if you're learning async and await, this is not what you do. Like 95, 98% of async and await code is completely different than this, right? You don't want to use async void. You want to, it's async task all the way down and all the way back. So one reason why you don't want to do an async TCP/IP chat application in order to learn async and await, one reason is your learning curve is far, far, far bigger with learning that other technology, TCP/IP. And the other reason is you end up with several of these kind of things, several of these kind of methods that are not actually normal async and await usage. This is more of an obscure advanced case, all right? So, yeah. Bottom line, do not write a TCP/IP chat application in order to learn async and await. That was a little long, sorry. But now we're actually at a minimal correct implementation. I like this. We are good. I actually like this well enough that before I even do anything else, I'm going to go ahead and commit here and say day 10, minimal correct implementation. And I'm feeling good, because this is actually a good point. I'm going to keep the series going just a little bit longer, because one thing I want to demonstrate, so I think today I'm going to clean up some of that serialization code just because that's bugging me. So if you want to, stop watching the stream here, that's totally fine. I'm going to do some more cleanup today on that serialization code. And I think tomorrow I'm going to, what is today, Friday? Today's Friday, so tomorrow morning I'm going to do a command response, okay? So far, all we have is essentially like fire and forget, or, it's not really forget because you do get notified if the write doesn't make it. But the idea is, right now all of our messages are just one way, there's no responses. Right, so that the client sends a chat message to the server sends a broadcast message to all of the other clients, not the client that sent it, and then we have this keep alive message that doesn't have any kind of an ACK, or if this is a ping and there's no pong. So we don't actually have any messages that cause a message being sent back. And that's a very common pattern in TCP/IP. So what I'm going to do tomorrow is add a command. So we're going to take what we currently have and add like this command response kind of a message to it. And we'll look into what that looks like. And I'm going to try something that I've never done before tomorrow. We'll see how well it works. Okay, so we'll have a command. I think I'm going to make it like set my nickname, right? So then the server, instead of sending, what does it do right now? I can show you. So right now it says, this is a chat message from the other system here. Well, the other client is at this IP address and port, right? That's not really a great identifier. So I'm going to add a command saying, set my nickname to this. And if the nickname is already used, then the server is going to knack it. That's a not acknowledgement, and essentially saying no. And if the nickname is available, then the server can ACK it or acknowledge it. And this is a very common pattern with command response. So you send a command from the one side, and then the other side responds with ACK or knack. Yeah, so I think that we'll do that tomorrow. Today I want to clean up some of the code. just in preparation for that. I'm just going to close all this out. Where's my server? Just so I can build as I go. All right, I want to clean up some of the serialization code. Feel free to end the stream now if you're not interested in that kind of thing. All right, so what's bothering me about this code right now is a couple of things. First off, we've got this else if, several else ifs in this block. And then we've got like the same else if, essentially, in this chat connection. I think it's in here. Yeah, here, where we're actually writing out. And then we've got some duplicated code in here too. All right. So really what I want to do is I'm kind of thinking of actually pulling this, all the code in this write message, I actually want to pull out into that message serialization. Do I? Most of it I do. Not all of it. No, I don't. Thinking here. All right. So let's refactor some of this first. Like I said, I'm just going to pull out some of this common code. We always determine the length of the message, get the memory, and then allocate it to a writer. And then we always advance the pipeline socket by as far as we wrote. So I'm just going to tear out all of this common code, or duplicated code. I can see what we're doing a little more easily here. All right. Like that. Okay. So what I can do then is, yeah, let's go ahead and, okay, so what I'm thinking is actually I'm going to take all of this code, including the writer, and I'm going to move it into, yeah, I'm going to move that into message serialization, I think. The other option is, no, because I want the writer, because it gives me the position of how many I've written. So I'm going to keep the writer out here, but what I'm going to do is I'm going to move this into like a write message method on the writer. So let's go ahead and do that. So we started off with a span writer, having just very primitive support of I can write, you know, an unsigned 32-bit big endian integer. And now, actually, we have like this higher level where we have these conceptual writings, right? I'm writing the message length prefix, I'm writing the message type. And these actually, these lower level ones are no longer used outside of this class. These could be private. And now I'm actually like bringing that up a whole nother level, and I want to say, I'm just going to write a message. And I'm also going to want to take the length of the message. Because this has to be calculated out. That can't come into this type here. So let's see here. So I'm going to write this message. And this is still a pretty low-level method because of that. So I'm going to take all this code out here. And of course, we need the writer. We need the writer. So this is actually the message length prefix value. That's what we're passing in here. We'll just cast it once instead of each time now. And we also need that writer, where we're writing to. Oh, which would be, it's this type, duh. All right. So now we can, this is looking a little simpler. Still throwing here, should be fine. All right, so when we're writing, we can now write a message with a specific message length prefix value. And you know what I'm thinking? If it wasn't for this exception, we could actually pull this out Well, no, I like having it in here because it really makes it clear all the bytes that are in each message. So I even I like this duplication even. I like that. I'm going to leave that in because this is exactly the bytes that get sent over the wire right here when we're sending a chat message. We can pull write message length prefix out into like chat connection or something like that. The disadvantage being then this would only define the message bytes, not all the bytes that are going out on the wire. So you could go either way with that one. I'm going to leave it the way it is for now because I kind of like it that way. Okay, so that looks good then. And then I'm going to come over here and say, I'm going to write this message out. And that's it. What we got here is that it's not, oh, right. We also need to pass in the message length prefix value. So the reason that this has to be, and cast it, thank you. The reason that I'm passing this in like as a separate parameter, it's not like the best API, you know, I'm not terribly wild about that, but the reason that I'm doing it is we have to calculate it up here in order to know how much memory we're requesting from the pipeline. And I don't want the writer to be aware of the pipeline. Okay, so this is being done outside of the writer, the span writer type. So we calculate the prefix, or we calculate the length prefix, you know, the actual length of the message. Then we get the memory that we need from the pipeline. And then I'm using this writer to actually write the message, which includes the length prefix. If we pulled that code out, where are we at? If we pulled this write message length prefix code out back into here, then we wouldn't need to pass this parameter at all. We could just write the length message prefix and then just say write message and pass the message. And that's really tempting. I like that. I think I am going to do that after all. This is Steve coding, where I double guess all my decisions and change my mind a dozen times in 10 minutes. Live coding right here. All right, so I'm going to do that. Let's just do it. The disadvantage to doing it that way, so the advantage is, you know, this awkward parameter goes away, which is really the main advantage. The disadvantage is right now these are the bytes that are actually sent out on the wire. And now we're getting, well, 4 of those bytes are being written over here, and then the rest of the bytes are being written over here. Oh boy, I really like that. But okay, we'll take it out just for simplicity here. So each of these is getting removed. We're removing this parameter completely, and we're going to be doing that once at the beginning of this. And instead of passing that parameter to this method, we're writing it out here. Okay, so now we've got a message length prefix that's being written out before we write the message. And that's fine. All right. Okay, so that should also work. We still have, let me just look through here. I think that this code is pretty much good at this point. Oh yeah, this is the other part of the serialization code I really wanted to clean up. We've got all this repeated, oh hey, you know, I still need more data, so I'm gonna return. Which actually, we added this code, was it yesterday? I think yesterday. So now we're actually checking for that whether we have a complete message or not, right at the beginning. So none of these should ever return false, actually. None of those should return false, unless we get a malformed message, which I'm not really dealing a lot with in this this simple chat application. I'm kind of assuming that the messages will be well formed, which again, if you're dealing with embedded devices on a, you know, using a well-established protocol, you know, even if it's a custom protocol, you know, that's not really something you have to worry about. Nobody's attacking you in that scenario. So I could just remove these checks Or I could do something, and I'm going to do this here, where, with the span writer, we kept taking like higher level and higher level approaches. So we've got that span writer over here. We started off with really low level stuff, and then, okay, well, now we can actually like write logical fields. We can write long string, for example, and write short string. And now I've got the right message, right? So this is like the highest level of them all. So that's fine, and actually all the rest of these can be private now. I probably should make those private. I'll do that real quickly. So really the only thing that is public is write message length prefix and the write message. Everything else is only used by write message. So I'm just going to make all of these private at this point. Okay, that should still compile just fine. Just cleaning up the API a little bit. The less public API there is, the less you have to support. Now what I want to do is kind of the same thing to my sequence reader. So I've got try read big endian right now. We don't even have, like logical overloads like, hey, I'm reading my message type, right? I haven't even done that part yet. We did add some of these for try reading a long string and try reading a short string. So let's go ahead and let's add in here. We can do, like we did with the other, like we did with the span writer, we can add in try reading, like message length prefix and stuff like that, right? All our different fields. What do I want to convert over here? So like message type, really all we need is message type, right? We don't even need these really. I'd want message type and length prefix. Okay, I'll do that. So I'm going to say try read message type, and this is an extension method on a reference struct again. Sequence reader byte. I should just copy this instead of typing it all out again. All right, and in this case, we have the value that we're returning is going to be an integer in this case. So this is a 32-bit integer. So actually, I think it's, we just do sequence reader.try read big endian, which is out int value. Right? What am I missing? What's the problem here? The out parameter value must be assigned to before a control leaves the current method. Oh, right, because I'm declaring another value. What I want is out value. Right. Can I convert from out int to out short? Oh, this shouldn't actually be nullable. Okay, there we go. So now that's working. And we can just make that really simple there. And then the same thing for try reading the message length prefix. Is that what I'm calling it? Now in this case, I actually want an unsigned integer, and I'm just gonna make this a little bit cleaner by doing that cast in here. So this is going to be, so I'm gonna need like an signed value here. Actually, I can declare it right in here, out int signed value. And then I'm going to say my value is the casting of that signed value, and then I can return the result. All right. Okay. So this is, now we can read that message length prefix and get a signed value out. If I really wanted to, I could like use something similar down here. Oh, no, that can't be signed anyway. Okay, so, all right. see here. So I'm going to change my reading to use these more like logical ones, although they don't really actually change the behavior at all. So this is going to be try read message type. And this one's going to be try read length prefix. Which I'm calling message length prefix here, so I'm just going to change this to, I can't rename it. Okay, I have to go over here to rename it. Try read length prefix. All right, so now I can say out var length prefix, and it's already cast to the appropriate type. That rename didn't pick this up. Okay. All right, so that should work. Let's build again. All right, so that didn't really clean up the code a lot. It makes it a little bit easier to read. But what I want to do next is I want to read. I'm trying to decide how to do this here. So try read message is really what we want to end up with. The question is, do we want to have like an intermediate try read broadcast message, try read chat message? And I'm kind of thinking probably not. What I want to do is just jump straight to the try read message. So yeah, let's go ahead and so what I'm going to actually end up doing is copying all of this code. Pretty much all of this code into a all this code or most of this code? Most of it. This part here, the unknown message types, is going to be tricky. So I'm going to have to be careful when I break out this code. But what I want is a try read message now, right? So just like our serializing out, I'm now bringing my serializing in up a notch. We're bringing this abstraction up a bit. So let's say public static boolean try read message. Let me just paste this in first. And we're going to have a similar situation here. So we're going to read in the sequence reader. We're going to return a message. Now the thing with our return type of the message here is when we return, so here's how I want the semantics to work. When we return false, that means we need more data. So false means you have an incomplete message. We also have to handle all of our message types, including keepalives, and then also have a way to say, I read a message and consumed it, but it is not a message that I recognize. So for that situation, I'm thinking I'm going to return true, like we read a message, completely read the message, but this message return type is actually going to be null. So this is going to be null, and this not null when true is no longer true, because we can have a message being null with the return type being true, or the return value being true. I think that's the cleanest way to represent this here. So first we start by reading our length prefix, and we say return false if that's not sufficient. Okay, so we need to set message to null first. And when I'm returning false, the fact that message is null doesn't actually mean anything. If I return true, then if message is null, then that means we read and consumed an unknown message. Okay, so we check our, we need a max message size in here, don't we? Fair enough. Okay. So we can pass in, let's just say this is an unsigned integer, maximum message size. Passing this into our parsing options, or parsing method. All right. The other option is to actually read the length prefix outside of this method, and then we can do the comparison and all that stuff outside. And then we can also determine if we have our complete message before we even call this method. But for now, I'm just going to say this is good. Okay, so then we try to read the message type. Technically, this should never fail, but if it does, I'm just going to return false. And then we have, if our message type is 0, again, this should never fail because we should have a complete message by this point. But if it does, I'm just going to return false, and then I'm going to set in a message to the new chat message and return true. We have found a message. We have consumed one. Again, here we're just returning false, and same down here to read the fields of our broadcast message, and then we can return the broadcast message if it is available. All right, now this one, ignore unknown message type, so we advance our sequence reader by the length prefix minus a message type length. So this is all still correct. This is still the same thing. Okay, so this will work pretty well. So we are we are returning this, or we're consuming this message in the sequence reader. Message is going to stay null, and we're going to return true, saying I have consumed a message, but it is not one that I recognize. All right, so I'm going to copy this comment out, though. Well, okay, so I'm going to say return null. Well, okay, so we're going to say we're not really returning null, but the out value is null. I'm just thinking of the proper way to word this. On return, actually, I'm going to, okay. Message is null. For unrecognized messages. I'm just putting that comment in here because I know me. If I see, a Boolean out, Boolean returning out parameter method that returns null, or where the out parameter is still null but it returns true, that's unusual. So this is just a comment saying we're doing this deliberately. Message is null. Be all right. Okay. So now we can actually come back over here to our chat connection and delete this. Boom. All right. So now we can say, actually not quite delete it, because I want this code in here. So we'll delete it in just a moment. So if not sequence reader dot try read message. So now I've got this concept of, now we've got all these multiple memory blocks coming in the sequence reader, and now I have the ability to conceptually parse a complete message with just a single method call. So we need a max message size. Pass that in. And we're going to pull out our message. And if this is false, this is where we still need that this code saying, all right, telling the pipeline, I have consumed up to, I've consumed everything up to the beginning of this message, and I've observed all of the rest of the buffer, and there is not a complete message there. So I need more data. All right, so now instead of doing this a dozen times in this method, we're doing it once. And this will, I like that, especially because we're adding more message types tomorrow. So this code would only get worse. I like that we're cleaning it up now. So now we can actually get rid of all this code that got moved into our almost all the code. Okay, let's just delete most of the code here, because what I want to keep here is when we do have a message coming out, we want to ignore unknown message types for sure. So when we have a message coming out that's null, that's an unknown message type. So if the message is not null, then we're going to add it to our result array, and now we can delete all the rest of this. Then we advance the pipeline as far as we've read. So now this code, I like this code a lot better, where this method is now parsing as many messages as possible out of the sequence, or the read-only sequence that we're given from the pipeline. So we've got possibly several buffers, and we're using this sequence reader. It will read a single message out if it can. So we're in this loop where we can pull out multiple messages in a single socket read, or in a single call from our pipeline. That's totally permissible. And so we end up with a collection of messages that we end up parsing out of here. And we're properly telling the pipeline we need more information, or we've consumed all of this data. Okay, so this code is still handling talking to the pipeline, but it's not actually handling parsing the messages. That code has moved into our serialization, our message serialization type over here. So I really like this. We're very symmetrical now. So our chat connection is handling, so the message serialization type is now handling, here's how messages are actually encoded, here's how they're actually parsed, and our chat connection is now handling, I'm parsing things from the pipeline and I'm serializing things into the pipeline. So all of this code, this while code, and handling, advancing the pipe and all that belongs properly in this type. And same thing when we're writing, where it's handling getting the memory from the pipe, and it does actually handle this part with the write message length prefix. I pulled that out, so it's not fully symmetrical, but it's close enough. All right, so I'm pleased with where we're ending up here. And the message serialization, the same thing. I'm just going to run our code here, compile and run just to make sure it's still working. And I think we're in a good place for tomorrow. So I can connect, I can send messages, we can stick another client up here, it can connect and send messages. All right, so we're in a good place. The serialization code is cleaned up a bit. I'm feeling really good about tomorrow. Tomorrow we're going to take a look at adding some more message types, which is one reason why I wanted to clean up this code. We're going to be adding some more message types and demonstrating like a command response kind of way. So this has been part 10. We'll see you tomorrow for part 11, the continuing series. Thanks for watching. We'll see you.